Let's face it, the universe loves to surprise us. Just when we think we've got a handle on things, a comet streaks by, a star explodes, or we discover a whole new planet. That's right, a planet. You see, Uranus wasn't just found, it was stumbled upon, a celestial serendipity, by a musician-turned-astronomer named William Herschel. More on that later. Uranus is a world of wonder, a blue-green giant cloaked in methane clouds, its axis tilted at a jaunty angle as if it rolled into its current position. Its discovery shattered the ancient belief that our solar system ended with Saturn. Suddenly, our cosmic neighborhood had gotten a whole lot bigger, and a lot more intriguing. We've been hooked ever since. Uranus compels us to push the boundaries of our knowledge, to venture further into the cosmos. It's a reminder that the universe is full of secrets waiting to be unlocked, and that every discovery leads to even more profound questions. But first, let's rewind the cosmic clock, travel back to the moment of Uranus's discovery, and trace humanity's fascination with this enigmatic ice giant. Get ready for a journey through space and time, a cosmic adventure that takes us from the telescopes of Earth to the icy depths of the outer solar system. Uranus, the seventh planet from the Sun, is unlike any other planet in our solar system. It's a giant, about 4 times the diameter of Earth. Instead of a solid surface, it boasts a swirling atmosphere of hydrogen, helium, and methane. This methane gives Uranus its distinctive blue-green hue, a color that hints at the planet's frigid temperatures. Uranus is classified as an ice giant, along with its distant neighbor, Neptune. This doesn't mean it's a solid ball of ice. Rather, its interior is thought to be composed of a slushy mix of water, ammonia, and methane ices, all swirling around a rocky core. Uranus spins on its side with an axial tilt of 98 degrees. Imagine a planet tipped over on its side, almost rolling along its orbital path. This unusual tilt gives Uranus the most extreme seasons in our solar system. Each pole experiences decades of continuous sunlight followed by decades of darkness. But Uranus's quirks don't stop there. It has a faint ring system discovered in 1977, a delicate collection of dust and ice particles that encircle the planet. And let's not forget its moons, 27 and counting, each with its own unique story to tell. The year was 1781. William Herschel, a German-born musician living in England, was scanning the night sky with a telescope he had built himself. A self-taught astronomer, Herschel was meticulously charting stars when he noticed something peculiar. A faint, disc-like object, unlike the pinpoints of light that characterized the distant stars, drifted through his field of view. At first, Herschel assumed he had found a comet. But as he continued to observe the object night after night, he noticed it wasn't following the typical path of a comet. It moved slowly, too slowly for a comet, and its orbit was nearly circular, not the elongated ellipse characteristic of these icy interlopers. Herschel's observations caused a stir in the scientific community. Astronomers around the world trained their telescopes on this newfound celestial object, meticulously tracking its movement and calculating its orbit. The verdict was clear. Herschel hadn't found a comet. He had discovered a planet, the first planet to be identified since antiquity. Herschel's discovery, initially met with skepticism, ultimately expanded the known boundaries of our solar system. It was a monumental moment in astronomy, a testament to the power of human curiosity and the thrill of unexpected discovery. The discovery of Uranus sparked a wave of excitement and curiosity among astronomers. Here was a whole new world to explore, a distant giant shrouded in mystery. Early observations, limited by the technology of the time, revealed tantalizing clues about Uranus's nature. Astronomers noted its unusual blue-green hue, a color that hinted at an atmosphere unlike any other in the solar system. They observed its slow and stately progress across the sky, a testament to its vast distance from the sun. And they puzzled over its strange axial tilt, so different from the other planets. Some astronomers proposed that Uranus had been struck by a massive object early in its history, a cosmic collision that knocked it on its side. Others speculated that the gravitational influence of a large undiscovered moon might be responsible for its unusual tilt. Whatever the cause, Uranus's tilted axis remained one of its most defining features, a celestial enigma that fueled scientific curiosity for centuries. Despite the limitations of their instruments, early astronomers laid the groundwork for our understanding of Uranus. They provided the first glimpses into its nature, its size, its color, and its peculiar motion. These early observations, fueled by curiosity and a thirst for knowledge, paved the way for future missions of exploration. Fast forward to the late 20th century. The space age ushered in a new era of exploration, allowing us to send robotic emissaries to the far reaches of our solar system. In 1986, Voyager 2, a spacecraft on a grand tour of the outer planets, made its closest approach to Uranus. Voyager 2's flyby of Uranus was brief, lasting only a few hours. But in that short time, the spacecraft beamed back a treasure trove of data, revolutionizing our understanding of this distant ice giant. Voyager 2's cameras captured stunning images of Uranus's blue-green atmosphere, revealing subtle cloud bands and storms. The spacecraft's instruments peered beneath the clouds, providing the first detailed measurements of Uranus's atmospheric composition and temperature. Voyager 2 also discovered 10 new moons orbiting Uranus, small, icy bodies with names drawn from the works of Shakespeare and Alexander Pope. Perhaps Voyager 2's most remarkable discovery was the confirmation of Uranus's faint ring system. The rings, first observed from Earth in 1977, were revealed in exquisite detail by Voyager 2's cameras. The images showed that Uranus's rings are composed of dark, icy particles, likely the remnants of shattered moons or captured comets. Voyager 2's flyby provided a wealth of information about Uranus's atmosphere, painting a picture of a dynamic and complex system. The spacecraft's instruments revealed that Uranus's atmosphere is primarily composed of hydrogen and helium, just like the gas giants Jupiter and Saturn. However, Uranus's atmosphere also contains a significant amount of methane, which gives the planet its distinctive blue-green color. Methane absorbs red light from the sun, reflecting back the blue and green wavelengths that we see. Voyager 2's measurements showed that Uranus's atmosphere is surprisingly cold, with temperatures plunging to minus 357 degrees Fahrenheit, that's minus 216 degrees Celsius. The spacecraft's images revealed faint cloud bands in Uranus's atmosphere, suggesting the presence of winds and storms. However, Uranus's atmosphere is much less active than Jupiter's or Saturn's. Scientists believe that Uranus's internal heat source is weaker than that of the gas giants, leading to less atmospheric convection and fewer visible storms. Uranus's rings, while not as prominent as Saturn's, are no less captivating. Voyager 2's images revealed 13 distinct rings, each composed of countless icy particles ranging in size from dust grains to small boulders. Unlike Saturn's bright, icy rings, Uranus's rings are dark as charcoal, reflecting very little sunlight. Scientists believe that Uranus's rings are relatively young, perhaps only a few 100 million years old. They are likely the remnants of a moon or a group of moons that were shattered by a collision with a comet or asteroid. The resulting debris, trapped in Uranus's gravitational grip, continues to orbit the planet in the form of these delicate rings. Voyager 2's observations showed that Uranus's rings are constantly evolving, with particles colliding and exchanging energy. Some rings are held in place by the gravitational influence of shepherd moons, tiny satellites that orbit within or near the rings, keeping the particles in line. Uranus's rings, a celestial ballet of ice and dust, continue to fascinate astronomers, offering clues about the dynamic processes that shape our solar system. Uranus boasts a diverse collection of moons, each with its own unique story to tell. Voyager 2 discovered 10 new moons, adding to the 5 that were already known. Today, astronomers have identified 27 moons orbiting Uranus, ranging in size from small, irregularly shaped bodies to larger spherical worlds. Many of Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope, reflecting the planet's association with the heavens and the arts. Titania and Oberon, the largest of Uranus's moons, are named after the queen and king of the fairies in Shakespeare's A Midsummer Night's Dream. Miranda, another intriguing moon, is known for its chaotic surface, a jumbled landscape of cliffs, canyons, and grooved terrain. Scientists believe that Miranda may have experienced a violent past, perhaps a series of impacts or internal upheavals that reshaped its surface. Uranus's moons, a diverse and icy entourage, offer a glimpse into the rich history and complex processes that have shaped this distant planetary system. While Voyager 2's flyby of Uranus revolutionized our understanding of this ice giant, it also raised more questions than it answered. How did Uranus acquire its extreme axial tilt? What is the internal structure of the planet? What are the detailed compositions of its atmosphere and rings? To answer these questions and more, scientists are eager to return to Uranus with a dedicated mission. A future mission could orbit Uranus for an extended period, allowing for detailed mapping of its gravity field, magnetic field, and atmospheric dynamics. A probe could be dropped into Uranus's atmosphere, providing in situ measurements of its composition, temperature, and pressure. And a lander could touch down on one of Uranus's moons, revealing the secrets of these icy worlds. Further exploration of Uranus is crucial not only to understanding this enigmatic ice giant, but also to unraveling the mysteries of our solar system and the universe beyond. The exploration of Uranus, from its accidental discovery to the groundbreaking observations made by Voyager 2, has profoundly impacted our understanding of the solar system and our place within it. Uranus has challenged our assumptions about the formation and evolution of planetary systems, revealing the incredible diversity of worlds that exist beyond our own. Its discovery expanded the known boundaries of our solar system, reminding us that there is always more to explore. Uranus's unique characteristics, from its extreme axial tilt to its faint rings and diverse moons, have provided valuable insights into the complex processes that shape planets and their environments. As we continue to explore Uranus and other distant worlds, we gain a deeper appreciation for the vastness and wonder of the cosmos. Each mission, each discovery, brings us closer to understanding our place in the universe and the intricate connections that bind us to the stars. Let us continue to explore, to question, and to marvel at the wonders that await us in the boundless expanse of space.